Today's video will discuss triangle congruence proofs, ASA, AAS, CPCTC, and HL, hypotenuse leg. So for example 1, we're given that segment TM bisects angle HMA and angle HTA. We're trying to prove that triangle THM is congruent to triangle TAM. So I have a 2-column proof that I've already started with the first statement and also with the first reason. The reason is given because of what I just read above. The last statement will be what we're trying to prove, but the reason is not proved, okay? So now, as you can see, I'm annotating based off of the first statement that segment TM bisects angles HMA and angle HTA. Now, what I'm looking at is the actual angles that were created. So angle AMT is congruent to angle HMT. Why is that? Because of the definition of angle bisector. So if you are not sure what to put for the reason, typically if you look one number ahead on your statement and look at keywords, you can kind of figure it out. So I'm going to go ahead and annotate again. And remember, your vertex or your angle is the middle. So AMT and HMT, the M was the angle. Now for the second one, angle ATM is congruent to angle HTM. So I'm going to look for my T for both angles, and that is what I'm going to put a double arc mark on. I can't use a single arc mark because it would say that it's similar. It's congruent to angle M and it's not. But I am going to use the same reason. Definition of a bisector, or I could be more specific and say definition of an angle bisector. So far, I see that I have 2 angles, but I need something else. So the next statement is going to be segment MT is congruent to itself, segment MT. And we've already learned in the first video that that's known as the reflexive property of congruence. And you have to go in order, so it has to be consecutive. I have an angle, a side, and another angle for both triangles. And finally, I have enough information to prove that triangle THM is in fact congruent to triangle TAM. And now I just have to tell the reason why I think that's true. And based off of what I've annotated on the figure, it's because of ASA, which is angle, side angle. And the steps that I used to prove it were 2, 3, and 4. All right, so for example 2, we're given that angle L and angle G are right angles. We're also given that segment OL is congruent to segment DG. So all of that is annotated on the figure. I went ahead and set it up in the statements. You can skip it around however you need to. For me, it made sense to go ahead and make my second statement go with my first statement. So triangle OGD and triangle DLO are right triangles. And that's based off of statement 1. It said that angles L and angle G are right angles. So therefore, that's the definition of a right triangle. So we can move on to statement 4, which is segment OD is congruent to itself. So if you flip the triangle around, you will see that the O and the D match and the D and the O match, and that's reflexive property of congruence again. So what I want to do is just go ahead and mark it on my figure. And I'll notice this time that I only have 2 things marked. So my last statement is my proof that the triangle OGD does, in fact, it is congruent to triangle DLO, and it's by HL. H means my hypotenuse and L means my leg. And the steps that I used were 3 and 4. I can only use this reason if I have a right triangle. That's the only time. Finally, for example 3, we're given that segment AN bisects angle BAD, and we're also given that angle B is congruent to angle D. So I'm annotating the actual bisecting, what happened of the angle, and I'm also going to annotate angle B is congruent to angle D. You could wait to do that, or you can just go ahead and do it since it's in your given. So based off of statement 1, I know that angle BAN is going to be congruent to angle DAN. And the reason will be because of the definition of an angle bisector. Statement 1 already told me that segment AN bisected the bigger angle, angle BAD. So that was the definition of an angle bisector. We can move on because I see that we have two angles already. They also share a side. Those both triangles share a side. So that's my next clue as to what to write. And that's going to be that segment AN is going to be congruent to itself. Segment AN. We just talked about that in the previous example. That's called the reflexive property of congruence. And so far to the side, this is what I do. Again, this is not typically what you would do when you're writing proofs. I just keep up with my angles and my segments based off of the notation. So my fifth statement is saying that triangle BNA is congruent to triangle DNA. And now I can use those letters that I was keeping up with, but I have to go in a specific order. So I had angle, angle side on one triangle, and angle, angle side on the other triangle. Remember, I'm comparing two triangles, and they have to go in consecutive order, my markings. So I verified that by steps 2, 3, and 4. But I haven't gotten to the part where it says to prove, so I want to keep going. And what I'm looking at is the first two positions of my triangle congruency statement. So I see that segment BN is congruent to segment DN. How do I know that? Because of corresponding parts of a congruent triangle are congruent, CPCTC. And now I can actually prove what I was asked to prove above. Segment AN bisects segment BD. And how do I know that? Because again, the definition of a bisector. Remember, segment AN is what the vertical line up and down, and it's bisecting the segment going across segment BD. All right, that's all I have for you today. Like and subscribe. Have an awesome day.
Subscribe.